If imaginary numbers are at the heart of quantum mechanics, then presumably they are an inherent part of the universe. Or are they merely a mathematical construct? In other words, were imaginary numbers discovered or invented?
Oh, well, that's the key question, one of the key questions in the philosophy of mathematics. Mathematicians don't like to admit it, but if you look back at the history of mathematics, a lot of important mathematics was developed because it seemed to be a pattern or a game that nature or God also plays, not just a game that one mathematician invented one Sunday afternoon when he had nothing to do.
Nature is a perfect system. Its perfection is recognized in its efficiency. There is no excess information in nature's code. Simplicity is paramount. Efficiency is the general rule. When nature wants something done more than once, it duplicates the instructions. It makes a copy. Moreover, this copy is not merely a self-similar reproduction. The copy is only half written. Nature duplicates the other half in mirror image. One code, two equal and opposite directions. All life on the planet is created in mirror image. One half is duplicated onto the other. Mammals, reptiles, birds, leaves, in all living things a line of bisect can be drawn. And although it's rare to find an entire organism distributed equally in mirror image, the individual components of that organism at some level can be shown to follow this natural pattern. Mirror imaging is the first clue to understanding the symmetry embedded in our numbers. Base 10 is a perfectly balanced mirror image system. Most fail to see this basic property of our numbers because we've been taught to think sequentially rather than bilaterally. Consider our hands with an imaginary mirror between the thumbs. Notice how every pair of matched fingertips adds to 11. Nature exists in mirrored pairs, and numbers can reflect nature. Base 10 mirrors the anatomy of our physical digits. The central axis between our thumbs is 5.5, which is half of 11 and equidistant between each pair. Both 11 and 5.5 are mirror image numbers. Each is expressed outwardly from a central axis. Thinking bilaterally is about balance. In the previous example, we were actually measuring a value of 9 between digits 1 and 10. 11 was the result of adding duplicate ones. Let's throw out those sidelining ones altogether and think in terms of 0 through 9. Our new midpoint, 4.5, lacks the mirrored quality of 5.5, but we gain far more. Our paired sums now equal 9, the maximum value of the system. 4.5 now reflects the values of our thumb digits. Base 10 reveals itself as a system balanced by 9. 9 has perfect symmetry within base 10. To illustrate this, let's assign the first 10 multiples of 9 to our fingers, left to right. A profound relationship emerges. The right hand is a reflection of the left. All 10 digits are represented here. There are no other digits in the base 10 system. Each is duplicated only once and in the exact mirror image of its counterpart on the opposite hand. Note also the sum of each fingertip equals 9. Every number in base 10 has a unique balance with relation to the whole. Here's 1 balanced with its mirrored self, 10. And 2 balanced with 20. Note the point of equilibrium of each scale is a mirror image number. From one scale to the next, the fulcrum rises by a factor of 5.5, a reflection of our hands. This is consistent throughout the system. 9 provides the balance for each scale. 5.5 could be interpreted as 5 plus 5, which reduces to 1, the parent number of its scale. Likewise, 11 could be interpreted as 1 plus 1, or 2, the parent number of its scale. This idea of summing the digits of a multi-digit number is called reducing, or finding the digital root. It is a common practice in our new paradigm. Here's 3 analyzed against its mirrored self, 30. Note 12, 1 plus 2, is a mirror of 21, 2 plus 1. Both equal 3. 16.5 also sums to 3. 1 plus 6 plus 5 is 12, and 12 reduces to 3. 3 is the digital root throughout its entire scale. 16.5 is not a mirrored number, but it's only one step away from revealing its reflective nature. 16.5 could be reorganized as 66 by summing the outer 1 and 5. Or consider the center digit 6 as 5 plus 1, then redistribute the digits for balance. 1551 or 5115 are now possible. Consequently, these numbers are inverted palindromes of 1221 and 2112, the previous mirrored pair in the series. Please take a moment to perform your own digital root analysis of this central fulcrum in all its possible combinations. You'll find the same results regardless of digital makeup, variation, or sequence of calculation. Summing is a perfect science. Every pair of digits is a mirror reflection. Notice how the fulcrum and all the components reduce to 4. The scale for 5 and 50 is balanced, and with one reduction of its center digit, 27.5 can become a mirrored number. 6 displays perfect balance with its mirrored self. 33 and all the other components here reduce to 6. The same is true for 7. Each mirrored pair is separated by a distance of 9. 3 plus 8 plus 5 equals 16, which reduces to 7. 8 demonstrates the same symmetry. The center of 8's scale is also a mirrored number. Note the distance from each fulcrum to the next is always 5.5, the natural mirrored arrangement of our hands. Every fulcrum is a mirror image number, or can be arranged into one with one reduction of its center digit. 9 stands alone because its behavior is unique. Notice how 9 inserts itself at the center of its own scale between 4 and 5. 9 becomes the exclusive representative of the scale's center. If we expand the scale by an additional 9 in both directions, we find the internal relationships remain undisturbed. Of all the numbers, only 9 maintains perfect spatial proportion throughout the system. Notice how this scale implies 99 is a mirror of 0. 9 reveals itself as transparent, that is to say, it does not express value by virtue of its balanced unity. In this way, it functions exactly like 0. It's also the infinite maximum of the system. Notice how additional 9s placed at the end of 9 are absorbed into the center. 9 simultaneously represents the beginning, middle, and end of base 10. Imagine 9 and 0 wrapping around a circle to meet at the top. The point of intersect is unreachable because 9 and 0 both represent the absence of value. They are infinite, just like the circle's center. In this way, a circle perfectly models the properties of any number system. The decimal system, our base 10 system, is enclosed and centered by 9.